During our research, we discovered a key limitation. Traditional methods like web dashboards, bootable USBs are not that reliable. Whereas Team Shambhala brought an amazing solution. Every old laptop, hard drive, or server that gets recycled still carries one thing people often forget about: data. Sensitive files, personal records, and even confidential company secrets can remain on these files. I mean, look, that's even when they get retired. Team Shambhala is tackling this problem. Think of a file that pretends to be a real disk. We make the file and connect it with the Linux, then treat it like a real block disk. Next, we make a partition on the fake disk. A partition is just like a slice of a disk. We format the partition with a file system. Now the partition has a real file system. Fake disk is created. After that, we build an ISO file using TinyOS. An ISO can hold files. We start KEMU, a virtual machine, using both the fake disk and the ISO. The virtual machine boots from the ISO and runs the wipe script. The script overwrites the data. Basically, all zeros and ones are converted to either zeros or Fs. The wipe finishes. We check the disk at the raw byte level using a hex dump. Hex dump basically shows the actual content and it proves the old data is gone. So once the data is gone, it cannot be recovered, right? That is what data wiping is about. We run a forensic tool like autopsy to double check if the wipe was real. At the end, we generate a verification certificate. Its hash is stored in open timestamps, which proves when wipe happened and makes the proof tamper resistant. We'll be presenting Agent Shredder now. Let's demonstrate the complete secure data wiping procedure using our custom system. We have Raspberry Pi connected to a storage device, and the Pi is hosting web dashboards showing real-time wiping progress and logs. We have created fake disk image inside a Kali Linux virtual machine of 500 MB disk image, which behaves like a real storage device. We've added sensitive data to act it as a real-world file. Next, we have prepared ISO image. Inside the image, you can see the wipe script is securely overwritten. We execute the wipe command through our Node.js backend server, while the front-end dashboard monitors everything live. As I have clicked Start Wipe, the circular progress indicator updates in real time and detailed logs appears in the progress. The dashboard also calculates the time already spent and the estimated time remaining for the wipe to complete. Once the wipe finishes, you can see a system is generating a certificate. A cryptographic hash of the wiped disk is created and pushed to open timestamps, produces a timestamp that serves as tamper-proof of erasure. Here you can see verification certificate being generated. The process creates an OTS file and publishes it to the open timestamps, which anchors the proof to the Bitcoin blockchain. This method is free, transparent, and ensures the proof cannot be altered. Next, we demonstrate forensic recovery. Using the dashboard, I have run the recovery tools, which analyzes the wipe disk to search for any recoverable files. Since the wipe was successful, the tool finds nothing. You can see the forensic cases folder. You can clearly see the test output showing zeros recovered file, proving that the erasure was complete. Finally, we look at the timestamp proof stored in our file folders. It can be independently verified online. This guarantees the event happened at a specific time and cannot be tampered. This is Agent Shredder, clean, checked and recorded by Team Shambhala. Thank you for watching.